In this video, I am going to give an example of application of Rolle's theorem using the function f of x is equal to e to the power x times cosine of x in the interval, closed interval, negative pi over 2 to pi over 2. Remember that Rolle's theorem states the following. If you have a function f of x, it has the following properties. X is continuous, f of x is continuous on a closed interval AB. F of x is differentiable on open interval AB, and f of A is equal to f of B, meaning that the function is equal at the boundary points. Then there exists a C, an element of A comma B. There is a point in between A and B such that f prime of C is equal to 0. And I'm going to take these conditions and apply these to this function. So first of all, e to the power x is a continuous function, so is a cosine of x on the real number line. So f of x is continuous. So condition number 1, f of x is equal to e to the power x cosine of x is continuous on the closed interval AB, negative pi over 2 to pi over 2. So that's great. Number 2, f is differentiable on this interval, on the open interval. So how do we show that? We can easily find the derivative of this. So what is f prime of x? Using the product rule, we get e to the power x times negative sine of x plus e to the power x times cosine of x. Very simple. And obviously we can see that this function is differentiable in the open interval negative pi over 2 to pi over 2. The third condition is that f of A is equal to f of B, which is this. Now, A in our case negative pi over 2, so f of negative pi over 2 is equal to e to the power negative pi over 2 times cosine of pi over 2, negative pi over 2, negative pi over 2. But cosine of negative pi over 2 is 0, so that makes it 0. Similarly, f of pi over 2 is going to be e to the power pi over 2 times cosine of pi over 2, which is going to give you 0 as well. So the third condition, f of A is equal to f of B, is satisfied. So by Rolle's theorem, there exists a point, let's call it C. So by Rolle's theorem, there exists a point C in open interval negative pi over 2 to pi over 2 such that f prime of C is equal to 0. So now I'm going to take the derivative of the function which we found somewhere here, right? So e to the power x, if I factor it out, I will have cosine of x minus sine of x. Okay, that's the derivative. But we are applying this derivative to a specific point. So it's going to be e to the power c times cosine of c minus sine of c. That's going to be equal to 0. Obviously, e to the power c is not 0. So we can get rid of it. Then it says that cosine of c minus sine of c is equal to 0. That says cosine of c is equal to sine of c. If I divide both sides by cosine of c, I get tangent of c is equal to 1, which tells me that c is gonna be pi over 4. Why? Tangent of pi over 4 is 1, right? So that's what it is. So we just took the function e to the power x cosine of x in the closed interval negative pi over 2 to pi over 2. And we satisfied all three conditions for the Rolle's theorem. And then we actually found the point C. C was, in our case, pi over 4, which belongs to the open interval negative pi over 2 to pi over 2. I hope that this discussion was helpful. Thank you very much.